Okay, so good afternoon, everyone. I'm Diego Domenici from Trust AT, one of the contractors of the Destination Earth initiative. We're here today for the sixth DestinE Roadshow webinar and specifically the fourth webinar in this series for the ESA use cases. This is for the Destination Earth Sea Ice Decision Enhancement use case, or DESIDE, led by David Arthurs from PolarView. This is a very interesting and a very unique application for the DestinE initiative, I would say. So just a couple of administrative things before we dive in. First of all, this webinar is being recorded. The recording will then be posted both on the Destination Earth YouTube channel and also on the event page. We will have a Q&A session near the end of the webinar. So please, if you have any questions during the presentations, feel free to post them in the Q&A session or in the chat, and we'll come back to them. This webinar will be delivered in a series of short presentations by the participants in the use case, and then we will have a general section at the end. So I will pass the floor now to David Arthurs, who is leading this use case, to give a short overview and then onto the individual presentations. Thank you, David.
Great. Thank you very much. Welcome, everyone. So today we're going to talk about the Destination Earth Sea Ice Decision Enhancement project, short form DESIDE. What we're going to do is I'll give some background and context for the project. We'll then give you 3 live demonstrations of different components that comprise the DESIDE offering. And because we can't cover everything in the demonstrations, we'll give a little quick overview of some additional capabilities and then open the floor to questions. I'm joined today by Lasse, who's going to talk about the ICC app, and I'll talk about the DESIDE dashboard, and then Stefan will talk about PolarTap. So a bit of background. We're one of the ESA's Destination Earth use cases. We're here to demonstrate the use of the DestinE infrastructure, and in addition to that, provide actionable information to decisions for decision support to a variety of end users. So our end users consist of ship operators who need to navigate in the polar regions, analysts who need to look at data about the changing polar conditions and the implications for shipping, and researchers who want to do more in-depth analysis of polar data. In using our platform, there aren't too many user requirements. Ship operators obviously should be familiar with polar operations. Analysts will not require any special prior experience. And if you're a researcher using our capabilities there, you'll have to have more sophisticated knowledge of Python programming and how to use cloud computing. So the context. Our objective is to aggregate diverse information and provide common products across jurisdictional boundaries. At the moment, a lot of data about the polar regions is divided up depending on which country's area you happen to be in. Provide new forecasting products to improve decision-making, and most importantly, to customize delivery of all these products to different user communities. The drivers for this project are, first of all, regulatory compliance. And I'll be talking more about that in a moment. But if you're traveling in the polar regions, the International Maritime Organization has requirements for what information you need to be able to access. And also the fact that climate change is quickly and dramatically changing conditions at both poles, which means that previous knowledge isn't necessarily applicable to the future. And And so all sorts of groups that operate in the polar regions need new information. And this includes fishing vessels, tourism, research, oil and gas industries, etc. So I talked about the regulatory requirements. Each country has its own requirements, but sort of overarching all of this is the International Maritime Organization, which has something called the Polar Code, which applies to larger vessels. And it requires a lot of things of vessels traveling in the polar regions: the design of the vessel, its construction, what equipment needs to be carried, training of the crew, planning, a lot of things. But in particular, what we're interested in is the information that a vessel is required to have. So when a vessel is planning the voyage, it needs current information on the extent and type of ice and icebergs along the route. And it's supposed to access statistical information on what has happened in the past, hopefully as a bit of guidance on what a ship might expect along its route. And it needs a means to receive and display all of this information on the ship. One of the things that the Polar Code talks about is the so-called Polaris calculation. Polaris stands for Polar Operational Limit Assessment Risk Indexing System. Long title, everybody just calls it Polaris, which assesses the limitations of a ship operating in ice. The algorithm considers information about the ice, so ice concentration and stage of development, whether or not the ice is decaying. Ice in the summer has different properties from ice, which is harder in the winter, and the polar class of the ship, i.e. the design of the ship and what the designers say it can, what type of ice it can go through. And all of that information is taken in, and out of the algorithm comes classes of operation. So down in the left corner here, you'll see an ice chart, and you'll see the Polaris calculation applied to that ice chart on the right. And depending on the polar class of the ship can have normal operations, will experience operational risk, which therefore means it needs to basically go slower, or it should consider not going into the area. So we'll show you some of this in the capabilities to come here. Benefits to polar operations in society come down to increased safety, reduction of pollution, and very importantly, protection of sensitive environmental areas. So we take all of this information and we provide it in three different forms for three different purposes. First is support of execution of voyages in the polar areas. So this is targeted at ships that want to avoid or navigate through sea ice. The next level is planning support. So supporting the ships, the ship owners, and others in guiding the planning of a voyage, either in the short term, i.e. a voyage that's happening in the near future, or longer term, if you're talking about policy and you want to know, say, how to design a ship for what conditions the forecasts say can be expected in the next decade or something. And finally, strategy and policy support. So, for example, what the regulators in a country think should be done to manage shipping in their area of responsibility in the future. To do this, we are going to be taking advantage of Destination Earth in three ways. So Destination Earth provides a platform which a computing platform on which some of our processing will be hosted. They provide a data lake, from which we will access the information we need. And in particular, we're talking about Sentinel satellite data and Copernicus Marine Service data. And finally, they have two types of digital twins, which provide short and long-term forecasts. So the short-term forecasts are about 4 days, and that helps us with tactical decisions. And the long-term simulations are decades in length, and that helps with the long-term strategic decision process. So we take data, both the past, current, and forecasted information on a whole lot of parameters that impact ships in the polar regions. So sea ice, snow thickness, icebergs, mid-ocean conditions such as currents and waves, wind, temperature, visibility, etc. Plus the satellite data, mostly Sentinel-1, because we use Sentinel-1 synthetic aperture radar data because it can see through clouds. It's always cloudy in the polar regions, and it's often dark, and it can see in the dark. We then process that data using various models, etc., including machine learning. And we have the data processed in a form suitable for our different end user groups. We then create information products, short, medium, and long-term forecasts for sea ice, the risk profiles, I already mentioned Polaris, and ways of optimizing the design of routes for ships traveling through the polar regions. And then we disseminate it through our 3 decision support platforms. And those you'll get quick demos of today. First, the ICC app. Lasse will give you a demonstration of that. The Polar Dashboard, I'll give you a demonstration of that. And PolarTep, and Stefan will give a demo of that. So just quick overview before we get into the demos. ICC is an app that runs on board ships. It gives you access to all the information you would need when navigating a ship, including Sentinel-1 images, ice charts, and the Polaris risk calculations. The app is designed for use on board and is suitable for low bandwidth and intermittent internet connections. The dashboard is more for strategy and policy. It gives you curated data. It allows you to calculate statistics and interact with the data in various ways, and also has a capability to do storytelling. And then finally, PolarTep, which is a research platform in the cloud, which has access to very large amounts of data, and provides very capable computing, including access to GPUs for machine learning, provides a Jupyter Notebook environment and an execution environment to do very large processing. So we're going to give you 3 quick demonstrations. They're going to all have the same theme, which is basically how to combine information needed for voyage planning. And that data will consist of Sentinel-1 images, human interpretation of those images, i.e. Ice charts from the National Ice Services, machine learning interpretation of the same images, and the Polaris risk assessment. So I will pause here, and Lasse will take over and give you a quick demo of ICC.
Okay, I will share my screen. Okay, I hope, David, can you see the screen? Then I assume everyone else can.
Yes.
Okay, otherwise please protest. Yeah, so ICC is the first of the three demonstrators. It is targeted to actual users on board vessels, ice-going vessels. It is designed for the very end user. So really the master mariner on board a vessel who would not log into the Destination Earth platform or so, but the back end of that app is running, for instance, on the Destination Earth platform. It uses hosting capabilities there, and it can use a lot of the data provided through the data lake, for instance. We designed the app listening to the users on board the vessels. And UX design and usability was really one of the main drivers for creating the app. It should be easy to use, understandable within ideally a few minutes, and you can start using it fairly instantly, at least if you have a background in polar regions and ice information. So all the interesting layers are shown in the upper right, and in the upper left you have some menus to do change settings, etc. It is not downloading automatically data because it is designed to be operated on ships and helicopters and airplanes where you cannot assume you have a proper internet connection, although this becomes less of an issue nowadays with Starlink, etc. But whenever you would like to update information, you need to do it manually. You can use that app even offline, and we have users using this on airplanes or helicopters flying over the ice, and of course on a variety of vessels and testing it. What we usually recommend for users who are operating in the polar regions, you could start with the low resolution data set, for example, the so-called ice charts by the weather services and ice services of the respective countries. For example, here you have a look at the latest ice chart from the Danish Meteorological Institute, the Greenland ice charts, but you can switch to the Arctic weekly ice charts, for example, from the US National Ice Center, or you can also display the Canadian ice charts, or the Norwegian ice charts, for example, showing more the region north of Europe. So if you, let's for example take the Greenland ice charts. As imagine you're on a vessel and you would like to go, and you can actually imagine that this software is running on your bridge. Let's assume you would like to go to Tasiilaq, to this settlement, and you know that there's on the way a decent ice concentration, which is marked in red here. You can also click on the polygon, and you see the so-called egg code. It looks like an egg, which is a very standardized ice information support system defined by the International Maritime Organization. You can also change the colors to stage of development, showing you, for example, that the ice on the way to Tasiilaq is brown, is old ice, that's at least a year old, which means it's usually a little thicker and harder to go through with an ice-going vessel. David also mentioned the Polaris risk assessment, so you can also do that calculation automatically, and then it colorizes the ice chart polygons with respect to the risk index outcome, which when it's negative, it is yellow or orange or red. You should be careful. I think it's called evaluated risk or operational subject to special consideration. Only if it's green or blue, you're okay to go. So here in that case, it's shown for a Polar Class 6 vessel. In the app, you can also change that, for example, to, let's say, Polar Class 2, which is pretty good. And then you see that all the colors change to green because your ship is certified to go through harder ice. The ice charts come to their limit when you actually would like to go into that ice polygons, because then you need to navigate within here, and then you just see one color. So that's a moment when you can then on demand download, for example, the latest high resolution Sentinel-1 or RCM imagery from the data lake, for instance. And because for ice changes like on hourly and daily basis, the value of information really decreases quickly with every hour. You can also show the age. So this Sentinel-1 imagery, for example, is 5 hours old. And the same actually counts for the ice charts. So here you see always the timestamp when the weather service created that information. So now the mariner on board has a better idea of what the ice structure looks like. So for example, black here means low backscatter regions. And in this example, these black regions are ice-free. And there's also, for example, a stretch of open ice here. Yeah, so of course that end is in the end a decision with the mariner, but it might be an option to use that lower ice concentration zone here, for example. If you're interested to know how the ice develops over the next days, you can also input an ice drift forecast in here, which is I have to visualize it, of course. And now I have to switch it on. Now we have it, which takes basically two different scenarios. The white arrow, so let's just show the white arrow, is basically a wind forecast, which is translated into ice drift, just assuming that ice drift is 2% of the wind velocity and deviates 25 degrees to the right or left, depending on hemisphere. So that is a very simple assumption, but in some regions, users told us that this is the most reliable ice drift forecast they know, the wind forecast. We also include from the Copernicus Marine Service, the so-called, for example, Topaz 5 ice drift forecast, which also includes ocean currents and ice physics, etc. Especially here in East Greenland, for example, where you have very strong East Greenland current, maybe the black Topaz 5 ice drift is more reliable. And then, like each point is 24 hours apart. Here's the timestamp of when it starts. So that means like this is tomorrow, this is 2 days later, and then 3 days later. And you have an idea of how the ice system changes until you're actually there with your vessel. The good thing with the app is you can, of course, always display your own position. You also know where we are. We are based in Bremen. Let's check where the latest Sentinel-1 imagery is over Bremen. It's just 8 hours old. Here you see Bremen. And of course, you can also use that on the other side of the planet, switching to the Antarctic region. And then you are, right now, there are much more people interested in the Antarctic because there's a lot of vessels active there, especially here in the Antarctic Peninsula on the other side of South America, where a lot of expedition cruise vessels go there every year. And you have the same kind of information available. You have, for example, the Norwegian ice charts again, showing you the latest, etc., etc. So I can repeat everything here. So so ICC is a good example of using the Destination Earth infrastructure and building this into a web service, into an app, which then eventually is being used by a very dedicated and very specialized group of users, in that sense, polar shipping and mariners on board. So I think I used my 10 minutes by now and stop sharing the screen here.
Excellent, thank you. Okay, next we are going to look at the DESIDE dashboard. What Leslie just presented is focused on specialized users on ships. Polar Dashboard is our most generic product that can be used by many people. It's easy to use. Hopefully you are seeing the dashboard. Somebody could just speak out whether they're seeing my screen here.
We can see it, David.
Excellent. Okay. So on the just a quick tour in the upper left here, we have a whole lot of data that's available. So there's data on sea ice, different seawater parameters such as tides and currents, waves, wind, etc. Lots of information that ships or people concerned about voyages in the oceans might want to know. I have chosen ice concentration. You can see the legend for the data here. You can see the data here. I'm going to focus on the east coast of Greenland, so I'll just zoom in a bit here. And you can see information about the data I've chosen. So the ice concentration comes from CMEMS. There's a description, etc. So I can take this data and let's say I want to know the ice conditions over the last year. So I'll go from January 1st, 2024 to December 31st, 2024. I'll select an area of interest just by defining a bounding box. I'll hit execute. And this will go off and calculate statistics for this region. So here are the statistics. You have time across the bottom. You have the mean, max, and min data for every data of the year. And you can see that a ship should expect that from sort of the end of mid-July to early November, there is no ice in the past year in this area. And if you were going at another time of year, it gives you some sense of what ice concentration you can expect and the variability in that. So that's a simple statistics. Just to give you something slightly more interesting, let's look at the same area. And all right, just get this reloaded. So we're going to look at a variety of information here. Let me get this set up. Okay. Perfect. So let's start with the satellite image. So this is a Sentinel-1 image. And as Lasse said, the ships like this because it gives it a great deal of detail, but sometimes it can be a bit hard to interpret if you're not an expert. Here we have pack ice, here we have open ocean, here we have landfast ice. But if you didn't know that, you might want to look at what a human expert would interpret. So here we have an ice chart, which is drawn by a human based on the Sentinel-1 image. And it tells you what ice concentration you can is in that image. And you can also look at the stage of development. So that's one way of looking at it. The trouble with ice charts is that you have a human in the loop, so the human has to have analyzed the data. That can take time, which means the ice charts are sometimes a little bit out of date. So instead, and this is more experimental in a sense, but all right. We have the computer interpretation of that image. This is provided by the Danish Meteorological Institute, and it's based on a machine learning algorithm. And it can analyze the data, the Sentinel-1 image, much more quickly and in some sense in higher resolution. So instead of polygons that you had in the ice chart, you have actual pixel level information. So if we combine the two, we can take the Sentinel-1 image, change the opacity, and you can see how the Sentinel-1 image compares to the machine learning interpretation. Or we can do the same with the ice chart and look at how it compares to the underlying Sentinel-1 image. And then finally, we can take the ice chart and apply the Polaris calculation, and we can change the ice class of the ship. So this is a Polar Class 1, the highest rated icebreaker. It can go wherever it wants in this case. But as we go down to lower class, you can start to see that we have red areas and orange areas, etc. So that is a quick introduction to the dashboard. And now we'll go to PolarTep and Stefan.
Thank you very much. So let me share my screen as well. Should be coming through. So now after all these nice and fancy visual presentations of the front end, you have to bear with me for some boring backend demonstrations. So how do we get all this data in? How do we get all this data processed? So if you're interested, so I start here from the PolarTep description. And as David nicely already pointed out in his slides, we have different areas, what we offer at the PolarTep. I'm going to show the machine learning part of it. So if you follow here, you will get more description as usual, but you can then of course access, as David said, the online workspace. So this is running in the cloud with a lot of data connected and so on and forth. So if you go there, if you're new, then you will need to be approved, but feel free to ask for an account there. Well, now let's go to the standard Jupyter Lab offering. And I already, oh wait, I have it open here. I already launched the session so that we don't have to wait for this and can spend the time more accurate. So we have the, I'm not sure how much into detail I should be going, but if you're familiar with online clouds and processing, so then you have seen this Jupyter Lab interface, I suppose. What you might see in addition, we have added a couple of applications down here that might be of interest. So some sample notebooks simply to get you started, and others I will come to them in a minute. So let's jump right into one notebook that we developed, and this is in the end powering the processing of ice charts, as David David and Lasse both just have shown. So in the end, you can look at the notebook, develop it. So you see we have, it's an interactive demo, so I can actually run it. So we see here also what we are going to generate is the sea ice concentration and state of development. So the ice charts that have been shown already. we are, in this case, I started a GPU profile. So we have a GPU available, which is important for our training the model. So and also for inference, to generate the ice chart on a regular basis afterwards. I spare you all the details of this. Maybe just one more point I want to mention here. So we are offering and using a tool which is called MLflow. So in this case, what we do is simply that we start run with MLflow. We connect to MLflow in order to track the experiments, in order to store models afterwards, and in order to share this and the results. So when I do this, when I actually run the code connecting to MLflow, this is here we have experiments and models in this tool. And for example, I have here an experiment run where you can see the let's look at the combined score. So there were what was it, 10 epochs with the various runs. So you see that it increased but also decreased. So it's a typical machine learning environment that you can connect to from your Python code to this MLflow. But now, what David has shown, like there are two things. So the one thing is that you want to pre-process the certain elements so that you have it fast, like for example, also for the ICC app, that you don't process things on demand, but some elements you want them to change the parameters and process also on demand. So we have what we call the headless execution here, and I just wanted to show you quickly. We have we can browse the jobs that have been here, and you see an execute notebook. So the notebook that I've developed is now exposed via an API, so that anybody, especially your app, can then use it. And well, you run it and get your results as David has been showing. Now just to one more element is now you run it within your environment, but you might want to give others the access to your environment. So this is what we then call what we do via a system called bring your own algorithm. So you offer your algorithm. So in this case, I selected the CI's algorithm. I provided a area of interest, time that I'm interested in. And in this case, since it's not running in my own workspace, but is offered by somebody else, I have to pay for it separately. It's not in part of my subscription. But how does this look like in the end? Well, you get the results once it's processed. So it's a bit more so headless execution inside of your workspace and this bring your algorithm outside. But in the end, and this is what I wanted to finally show, we get again this nice inferred images for in this case, I believe it's the state of development and the sea ice concentration, state of development. If I'm not mistaken, well, it's the run I've just shown. So for the latest image in the last 2 weeks that we found. Yeah, this concludes a very quick overview of the polar depth. David, do you want me to go into any more details or anywhere?
I think that's perfect. We'll follow up with people who want more detail.
Yes, please feel free to contact us afterwards if you have additional. I barely touched the surface of everything. Sorry for that.
Okay, I've just got 3 more slides before we get to the questions. So Stefan, if you can stop sharing. Perfect. Okay, back to 3 slides. So we've covered a lot, but all on the theme of ice charts and machine learning and that type of data. Just to say that other capabilities that we will be making available, first is access to RadarSat Constellation mission. For those of you who use SAR data, you will know that Sentinel-1B failed a number of years ago, and the Canadian RCM satellites were in great demand because Sentinel-1A wasn't providing the coverage that the two satellites used to. Sentinel-1C is now in orbit, though it's not yet commissioned, so hopefully that will take up some of the load again. But in any case, RCM data is of great interest. Additionally, we are putting the historic sea ice charts into a data cube, which will make them much more accessible and easier to analyze for people who want to look at the historic record of the ice charts and related data. So there'll be different types of data in this data cube, including the ice charts. So this will be a significant step forward for use of ice charts, which up to now have not really been readily available. And finally, this idea of right now you get a Sentinel-1 image, and then sometime later, a day or two, you get another Sentinel-1 image. Things change quickly in sea ice environments. And sometimes it would be helpful to get a sort of a guess at where the sea ice is going to go. So this capability takes an ice drift forecast model and applies it to a Sentinel-1 image and warps the image to try to simulate where the ice will move up until the time that we are able to acquire a new image. And so here you can see it in operation, and the ice appears to be moving. So that ends our presentation, and we are now available finally for questions. I think we've got at least one. But Diego, perhaps you could be the master of ceremonies for this.
Absolutely. Thank you, David, and everyone for your presentations. So we have one from a while ago that Andreas asked, actually two questions. These are both for you, David. The first one is, Andrea asks, what kind of snow depth products are you using in your approaches?
So at the moment, the snow depth comes from the Copernicus Marine Service. So for more information, please, there's complete documentation on that product at CMEMS.
The second question is about an initiative. He asks, are you cooperating in any way with the team working on an Arctic service on improving safety for shipping in the polar seas, led by Andrew Fleming within the EU-funded Arctic Passion project?
Okay, longish answer to that, I'm afraid. So in a sense, yes. Andrew is with British Antarctic Survey. British Antarctic Survey is a member of PolarView, and we have collaborated for decades on the information that's provided to mariners. And in fact, one of the most used sites to date is the polarview.aq site that ships access for Sentinel-1 and ice chart information. That is provided by BASS and by Andrew. There is a project's just starting up at the IMO to reassess the Polaris algorithm. That's very related to what Andrew's project has done. And we, with ESA funding, will be contributing to the IMO, and as a starting base, we'll be using the Arctic Passion work. So we're in communication with Arctic Passion. Arctic Passion's work is not directly part of the DESIDE project. So there's communication, and there will be further collaboration in the future.
Great, thank you very much, David. We then have a question from Georgios, I believe for Stefan. He asks, do you need any additional data or data of higher temporal or spatial resolution for increased accuracy? And what kind of data would that be?
I would pass the question to David again. He's the expert.
I'm not sure I understand the question.
Increased accuracy, I think, is the question. What data would we need for increased accuracy?
So,
Higher temporal or spatial
yeah,
resolution?
but do we need it? I mean, ships always want higher resolution. Most importantly, they want recent data. So because the ice is moving, it's not so much temporal. Depends what you mean by temporal resolution, but they need the data as quickly as possible. And that's what the ICC app attempts to do. There is a lag of at least 3 hours on Sentinel-1 images at the moment. But I'm not sure I'm getting at the meaning of the question. Giorgio, do you want to say something? Or can people say things, Diego?
I believe people should have the ability to turn their microphones on if they want to. Georgios, if you do want to clarify the question, feel free to do so. No microphone. Okay, then 1 second. Let's see if I can I can change that. In the meanwhile, I saw that also Simone
Someone's got their hand up.
Simone Azzori has his hand up. I'm not sure if he wanted to ask a question.
Oh, mistake. Okay.
Okay, no worries. Yeah, sorry. There's someone asked in the Q&A box. The projects mostly function on satellite, if I understand correctly, and some satellite data is accrued through the data lake of DestinE. Are there errors or biases which the project takes into account, such as non-random misclassification and saturation effects, etc.?
Is that in the queue? Okay. So the fact that the data comes from DestinE isn't really relevant. The data, DestinE is getting the data from a variety of sources, such as Copernicus Marine Service, and Copernicus Marine Service gets the data from various data providers, all of whom are experts at what they do. So in the sea ice community, that tends to be the ice services and meteorological institutes of the various Arctic nations. Are there errors and biases in the data? Undoubtedly. There is a lot of effort that goes into validation and sort of measuring confidence in data. You would need to go to the data sources to get more details on each of them. In particular, for the ice charts, there are disadvantages to having humans in the loop, but there are advantages. And one of the big advantages is that those humans are highly trained and very experienced. So you do have people who are the best at what they do. Do they make mistakes? Yes, but there's a high degree of confidence in the ice charts. Then we'd have to get into each of the, like there are dozens of different data products in the dashboard, for example, and each of those would require a different answer as to possibility for misclassification, etc.
Okay. Georgios, I give you the ability to speak, but it seems you've already managed to type it in the chat. He says data availability of sea surface temperature data twice a day. Would that help increase accuracy for the use case?
Twice a day, some of the data would be massively useful. Sea surface temperature, as an example, not so much. Because sea surface temperature for tactical navigation is not particularly relevant. That's more relevant for the longer term as an input into the weather and other oceanographic models. So those are people other than us that ingest that type of information. We are going to be implementing an algorithm for structural icing, which will use sea surface temperature. But it doesn't change rapidly enough to matter, I don't think, in that application. So once a day is fine. So, yeah.
We also have a question from Ilya that asks, how do you use, but I would preface this by saying, do you use climate DT adaptation data? Or how do you plan to use climate adaptation data if you do?
Yeah, we definitely plan to use it. So in two ways, because there are two models. So the 4-day forecast will be, well, let me say we haven't got access, or we're just now getting access to it, so we haven't got experience. So I'm going to answer this with what we would hope and like to do once we find out how well it works. But we can start to provide 4-day forecasts on many of the parameters we're interested in. So that's great for tactical use. Dramatically different, but perhaps of even more value are the decadal forecasts. We've had an initial look at the data. There are some concerns about the accuracy of those forecasts for sea ice, which the experts on our team are looking into. Apparently, I understand that the DestinE digital twin forecasts out a decade are perhaps overestimating the amount of sea ice, but that's yet to be discussed within the expert community. So yeah, really, I would say the thing that we're most excited about that we can't get elsewhere are the forecasts from the digital twins.
Thanks, David. So there's another question asking how the projects are connected to the digital twins of DestinE. So David has mostly answered this question now. To give a more organizational answer, these webinars are for use cases specifically for the ESA component of the DestinE initiative, that is to say the DestinE platform. So they are thought to validate the DestinE platform. Of course, the more they are integrated into the DestinE system and can use the other two major components, which are the data lake and the digital twin engine and the first two digital twins, the better. But again, as these were, let's say, prepared and started before all three major components were officially online, that let's say the foundation of the use case is not necessarily based on the data from the data lake or from the climate DTs. But of course, these are on the front line to being first to having full access to them and being able to use them well in their cases. So if there are no more questions, I wanted to know if anyone of the presenters had any closing remarks. Also, Stefan, you said that someone could reach out to you if they wanted more information. I'm not sure that people know where to find you or to have your email. So if you would like to write somewhere in the chat where people can find you or they can reach out to you, that's great.
I'll also mention that the beta dashboard is available, and let me emphasize the word beta, maybe even worse than beta.
Alpha.
Yeah, well, no, I think we're going the other direction. Is available at this website.
That's great. Okay. Well then, I have to say thank you, everyone. Thank you to the team who participated, and thank you for everyone for following along. As I said at the beginning, you could find this recording very soon on the YouTube channel for the Destination Earth initiative, but also on the same event page that you went to on the website to sign up. So thank you all again very much. Stay connected to DestinE by subscribing to the newsletter and checking out the website whenever you can for new updates. Thank you for the team, and I wish you all a great rest of the day. Thank you very much.
Thank you.
Thank you. Goodbye.